Hello everyone and welcome to the second lesson of the Solana Auditors Bootcamp. Today's lesson is going to be about the integration and unit tests. So I hope you are going to enjoy it and let's start. As you probably already noticed, I removed my camera so you can completely focus on the lesson. And you can see the agenda on the screen, so this is the first thing we are going to talk about. That's the agenda. First point is going to be about the unit tests and integration tests, as I would say both are really important in order to correctly test your Solana programs. Most of you already probably know what are these types of tests, what are the differences, but for those who don't know, we would like to describe the tests and also the differences. The second part is going to be about the testing using Rust, in this case Solana program test crate. Then we are going to talk about also the second approach, which is testing using TypeScript. I would say this is currently standard on Solana to use TypeScript for tests, as this is the default behavior for Solana programs written using the Anchor framework. Then the next point is about the Anchor manifest. The manifest in this case means the TOML file. So as you as experienced developers already probably know, then if you want to test your Solana programs using the Anchor and the TypeScript, in the TOML file you can specify really useful and helpful stuff. For example, how to clone or you want to clone the Solana programs from another cluster, let's say a DevNet or Mainnet. You can also clone accounts from different clusters using the manifest, and so on. Then we are going to talk about the forward in time, let's say issue, maybe issue. In principle, let's say you have your Solana program and it contains logic such that, for example, you initialize or someone initializes account, and the account is going to be activated after some period of time, let's say 7 days, for example. And now you as a developer would like to test this logic. So how to increase the type within the tests? There are, as you will see, there are solutions for both TypeScript and Rust approaches. So we are going to talk also about these solutions. And the last point is going to be about the best testing practices. So from the point of view of auditor and also from the point of view of developer, I will share my experience and knowledge, what I think is are the best practices for writing tests. So you can implement these in the development process. So this is the agenda of this lesson. We can go straight to the unit tests and the integration tests. For the purpose of description and also comparison of these two test types, we prepared this table, which you can see on the screen. And the first column is about the context. So within each context, we can claim what is the goal of each test type, and then we can also do comparison between each test type. So in this case, for example, for the purpose, which I think is like the most basic difference between unit tests and integration tests. So the goal of unit tests in this case is to validate the correctness of individual functions or small components in isolation. So for example, for your Solana program, which has one instruction or multiple instructions, and somewhere in the middle of instruction you call some kind of function which then performs math and computes, for example, trade amounts or something different, something like that. With unit tests, you just test the correctness of this particular function, not the instruction as a whole. On the other hand, for the integration tests, these should test the interaction between multiple components of the entire program within a Solana environment. So as you are already experienced developers within the Solana ecosystem, you probably already wrote tests within the TypeScript using also the Anchor framework. So these are actually the integration tests. So you are not just testing part of the instruction, but you are testing the instruction as a whole, or even the sequence of instructions, and also the Solana program as a whole, not just part of instruction or part of the specified Solana program. Then we can briefly talk also, let's say, about dependencies or execution time. So this is again pretty simple. The execution time is obviously lower for the unit tests, as you are actually testing only part of the instruction. You do not need to start the Solana environment and perform the instruction, but you just run the unit test and you check only part of instruction, so there is no overhead starting, for example, the validator. On the other hand, for the integration tests, again, we can talk in the context of TypeScript tests and the Anchor framework. So Anchor under the hood starts the Solana test validator for you. So the process is slower and the execution time is actually, I have written slower, yeah, but execution time is actually higher. For example, also the dependencies, the unit tests will not have a lot of new dependencies specified, or will not require to specify a lot of new dependencies, as these are again also written using the Rust. On the other hand, the integration tests, as I already mentioned, are for example written in TypeScript, so you need to specify a lot of new imports for the TypeScript tests. The table has actually the second part, but yeah, you can pause the video, you can read the rows. I think these are again pretty simple, and you can see the description or slash the differences between unit tests and integration tests. The last slide regarding this part is just the reference for the whole table. So yeah, these are the unit tests and integration tests. Now we can continue with testing using Rust. From now on, we are going to talk about in the context of integration tests. So yeah, we will not anymore talk about unit tests within this lesson. On the other hand, in the materials prepared, there is also an example for unit tests, so you can check the example for writing unit tests there. So you start with the folder structure. As you can see at this picture below the text, you can see the first file is anchor.toml, so you know exactly where is what is the root of this workspace. Then you have the programs folder. Within the programs folder, I called it Rust tests, or my program is called Rust tests, but your program is going to have a different name. In my case, the program is called Rust tests, and this is basically the common folder structure for programs written using the Anchor framework. So this is the program folder. Then you can see the manifest of the program. You can see the src folder of the program, and yeah, next to this folder you create folder called tests, and within this folder you can specify the file which is going to contain the tests. In my case it is called rusttest.rs, and yeah, optionally there is this fixtures folder, and this fixtures folder serves the purpose that we store programs that we want to include in our Rust tests that are for example, from DevNet or Mainnet, dumped from the different cluster. So, for example, your program interacts with Metaplex token metadata, but locally you do not have this program. You do not have the source code of the program, but you know that this program is on, let's say, Mainnet. You know what is the program ID of this program, so you can dump the program from the Mainnet, include it in this fixtures folder, which needs to be stored in the tests folder. There are actually multiple locations where it can be stored, but for me the most straightforward option is to store the program in the fixtures, which is then stored in the tests folder. And yeah, you store the dumped program here, and you can use it in your testing environment, which is going to be written in Rust. We will talk about this in the next slide. So yeah, that's the folder structure. And also the SBF program for CPI. Then you should also specify your dev dependencies. These dependencies, as they are marked as dev dependencies, they are not going to be included in the final deployed program. So you specify dev dependencies. You can see on the picture on the right, my dependencies in this case are Solana program test, which you will see. This is great for this is great for testing the program using the Rust. And then Solana SDK, MPO token metadata, which in this case is for purposes of some kind of functions for deriving metadata PDA. And I also use Anchor SPL in the tests. And for the informational purpose, you test using the command cargo test subf. Just not to forget, you can see in the right corner, I again specified or included the QR code. So this is QR code to the program test documentation. So if you would like to know more about the methods, let's say variables and so on, maybe examples, I'm not sure if there are also examples, maybe examples, you can check the documentation. But yeah, we are going to have also examples in our materials, so you can rather check the materials. Okay, so now more information about this testing scenario. So as I said, it uses program test, which is specified with the Solana program test dependency or crate. Under the hood, this testing scenario does not start the Solana test validator. And from my point of view, I would say it has more, or this testing approach has more control over testing environment. You will see in the later part of this lesson that you can manually set accounts, for example, or system variables and so on, which is not possible using the Anchor framework. It's not completely correct, because you can do it with the bank run. But yeah, without the bank run, there is no option to set, for example, a system variable or manually account. The next point is simple forensics from logs. I like this feature. Basically, when you run the tests, you can immediately in the command line interface see the logs of the tests. So you can immediately see the, let's say, the panics, errors, if or where the instruction failed, if the instruction succeeded, and so on. So I would say this is really great for the testing purposes. This is kind of similar to the Anchor framework, as Anchor also stores these logs somewhere. We are going to talk about this, but you need to check for Anchor, you need to check somewhere in some folder, but for the testing using Rust, you immediately see the results. And one last point regarding also the forensics. The tests written using the Rust and the program tests are by default parallel. That means if you have specified 4, 5, 6, 7 tests, each test is executed in parallel. But for, let's say, the forensic purposes, you would like to execute them not in parallel, but sequentially using one thread. So you can more simply read the contents of the logs. So you can basically, the debug experience is better. So you can run the command cargo test sbf, but this time with option test threads equals 1. That means the tests are going to be run only using only one thread. So basically this is the sequential behavior. Then I would like to talk about the source code on the right hand side. Again, these examples are also going to be stored in the GitHub, in the materials, so you can check yourself what are the contents of the tests, how the tests are written. But yeah, slightly to describe the workflow. So firstly, you can see you create the function. Basically, you specify Tokyo test macro that tells that this function serves the purpose of testing. First thing that you are going to do is create the program test, which is or the inputs of the function new are the program name, program ID, and the entry point of your program. Then optionally, as I was talking about the metaplex, you store the metaplex in the fixtures folder, and you would like to tell the program test that you want to add this binary file to the context, so you can actually test the CPI. So you specify program test, add program, and again with the program name, then the program ID, and the third parameter is none. This is quite interesting, as you do not have the entry point of this program, as this program is in binary format. So basically for you it's unreadable. It can be read only by your machine. So you do not have the entry point, so you specify none here. And the program test automatically reads the binary file from the fixtures folder and includes it in the program test environment. Then the next part is you start the environment, and now you can, I called it do stuff, but behind this you can basically create the instructions, input the data into the instructions, input the accounts into the instructions, then you create transaction from this, or you can see that's the next step. You create transaction, new with pair, instruction is basically the instruction you defined within the previous steps. You can again check the examples how it's done, and yeah, you specify the payer who pays for the transaction fees. Then you sign the transaction with the desired signers. You need to specify also the latest block hash, obviously, and then you can call function called process transaction with context, the context commitment. The commitment is basically the desired finality you accept. In this case, I have finalized. So yeah, and that's basically the workflow, how to write the test using program test. The part between, which is do stuff, is quite important, but quite important. Without this stuff in between, or without the part in between, you cannot test your program, because you need to specify the instructions there. But yeah, this depends on your program. You would like to test on the instructions, the program contains, accounts, input data, input parameters, and so on. There is second option that you can use to test the program using the Rust, which is not included here, and it's called, Anchor. Anchor has its own crate called Anchor Client. You can use it also with the Rust. I personally do not have much experience using this approach, so I did not include it here. But yeah, that's the, I would say, second approach you can use for testing using the Rust. But I think the Anchor client actually starts the Solana test validator under the hood, so it's quite a different approach, I would say. I think it's something like the TypeScript tests, but written in Rust. This is all I would like to say from this slide, testing using Rust. We will get back with the forward in time, but right now we can continue with testing using TypeScript. You are probably already experienced with this approach of testing, as I would say this is the standard on the Solana blockchain, but I hope you will learn something new, so let's continue. First point is that it goes hand in hand with the Anchor, as Anchor build actually generates IDL file and types file, which I think are both JSON files, and these files can be included within the TypeScript source code or within the test source code, and it dramatically improves the experience of testing. The second point is that the Anchor test actually starts the Solana test validator, which I think brings a little less control over the environment, because for the Solana test validator you can specify like parameters when you would like to, or when you want to start the validator. You can specify parameters such as Genesis programs, Genesis accounts that are going to be included there. But when the validator is started, you do not have the option to set system variables or set accounts, for example, as but on the other hand, you have this option using the program test and the Rust programming language. So yeah, a little less control over the environment. Then logs are stored within the .anchor folder. I think actually this folder is quite important and useful, as there are two important things stored. First is the logs. So when you run your tests, you can check the logs, you can see the outputs here, what are the outputs of the instructions, and so on. The second important part is that the test ledger of the Solana test validator is stored here, and it's really important for the purpose of let's say checking the state or maybe debugging. As you can navigate to this folder, you can start yourself the Solana test validator, and then go to the Solana Explorer, specify that you would like to see the localhost, not the mainnet or devnet, but the localhost, and with a nice graphical user interface you can basically see the state of your local ledger. For me, if I have, let's say, quite robust Solana program and I have a lot of tests, this is really helpful, as you can see basically all of the instructions, or sorry, all of the transactions that was executed in the Solana test validator. You can see the states of the accounts and so on, but with nice graphical user interface. Almost the last point is that I think the TypeScript is more widespread than Rust. As I already mentioned, this approach is kind of standard for writing tests on the Solana blockchain, so this is kind of advantage, as some of other developers are not as familiar with the Rust tests as with the TypeScript tests. Yeah, and the last point is the anchor test command, which you probably already know, as this is quite common for testing. When I was talking about the Solana test validator and the debugging process, when you can navigate to the .anchor folder and start the test validator here and check the state of the local ledger with the Explorer. There is also option for anchor test. I can't remember right now how it's called, but you can see it with the anchor help. there is an option that you can specify that anchor test will actually not shut down the Solana test validator, but it will the validator will still remain running. So you do not need to start the validator by yourself in the .anchor folder, but you can go straight to the Explorer and see the results, see the test, see the state. So this is from the TypeScript perspective. We will talk more about this stuff in the best practices, and also about this stuff in the forwarding in time. But for now, this is for like the informational purposes. Then on the right hand side, I just would like to show you the anchor manifest. We are going to talk about this in the next slide, but you can see, for example, the option that you can specify the validator, you can specify which program you would like to clone, you can specify other stuff here, for example, which tests to run, and so on. With the, I would say, the latest maybe release of the anchor, you can also specify the default toolchain for the anchor and the Solana, so this can be also quite helpful. As I said, there are multiple options you can specify within the anchor toml file, but for testing purposes, I would say the two most important options are cloning program or programs from desired cluster and cloning accounts from desired cluster. So you can basically reuse them within your tests. There are also some other options that are connected to the testing. You can specify some values to the Solana local validator, like the timeout before after starting and so on. To this day, I did not need to use them, but yeah, they might be important or useful for someone. So I will not talk about them in this lesson, but in the materials you will see, and yeah, we will include all of the options basically in the materials. But yeah, for the cloning of the programs. The first point, the Solana test validator actually starts with some amount or some of the mainnet programs, but definitely not with all of the mainnet programs. For example, the included program is token program, but this lesson I talk a lot about the Metaplex, and the Metaplex token metadata program is not in the Solana test validator, so you need to specify it in the manifest, so it is included within the Genesis. So yeah, what if you want to use different programs? So you have basically two options how to specify some kind of some mainnet program in the Genesis that is going to be included in the Genesis. First, this that you can import a .so file. As I was talking in the Rust part, you have the folder fixtures, which contains the .so file. In this case, for the anchor manifest, you can see on the picture that you have the test Genesis, you have the address, and you can specify the program, and you can specify the name of the program, which is basically the binary file. Optionally, you can specify the program as upgradable, so you can also test this logic, but by default it is marked as not upgradable. The second option, which is, I would say, more simple, because you do not need to clone you don't need to dump the program from the desired cluster. You can specify the URL of the cluster. In this case, in my example, it is mainnet, but it can be also the let's say the devnet, or you can use the different URL. And then you can specify the program ID, and the anchor will automatically clone this program from the cluster and include it in the Genesis. So I think this is the This is more straightforward option than the first one, but yeah, you can use both. Just for example, you can see the command Solana program dump. You specify the program ID, you specify the name you specify the name of the file you would like to store the program in, and this option tells this subcommand that you would like to clone from the mainnet. M stands for mainnet. If you would like to clone from devnet, then you should specify D. Again, in the right corner, just not to forget, you can see this QR code leads to the reference or to the documentation of the manifest, so you can see the documentation. But yeah, we will include all of the options in the materials that can be specified in the Anchor TOML file. The second thing I was talking about is cloning account from cluster. So let's say you cloned some kind of program from the mainnet or devnet, but this program also needs to have, for example, config account, because the logic of the cloned program needs to read some parameters for its functionality from the config account. The first option I would say might be to initialize the config account by yourself. The second option, you can clone the config account from the desired cluster, and you can include this, or let's say in more general sense, not the config account, but you can clone the desired account from the desired cluster, and you can include it also in the genesis of the local validator. So yeah, as I'm talking about this, for some testing scenarios, it might be helpful to also clone mainnet account. In this case, I specified mainnet, but yeah, it can be whatever. It can be also devnet, and you can do it with the Solana account. Again, option for mainnet. You need to specify the public key of the account, which is from mainnet, and then the output format of the account, so in this case JSON. Then within the Anchor TOML file, you can specify the address, starting with the test validator account, then you specify the address, and then you can specify the file name that the account is going to be taken from. So you start the Solana test validator, or Anchor starts the Solana test validator already with this account, and you can use this account with the tests or with, let's say, kind of CPI and so on. That's all from the Anchor manifest. As I mentioned, check materials for the remaining options you can specify within the Anchor TOML file. And now I would like to talk more about the second, let's say, issue option, and that's the forward in time, also with the Rust test and TypeScript test. So let's dive in. As I was already talking about this, in some cases it might be really useful and helpful and also powerful to be able to forward in time to properly test your Solana programs. So again, we split it into two options, and it's testing using Rust and testing using TypeScript. But first, testing using Rust. So actually there are multiple functions that can be helpful. You can see on the screen on the left side. The first function is called warp to slot, then we have warp to epoch, and then we have set sysvor. The third one is also helpful if you would like to set other sysvars, not only the clock. And yeah, then on the right hand side you can see the source code of the example. This example is going to be also stored within the materials, so you can check it by yourself within the context of tests. But briefly we can go through it. So I have specified this is the function that I created for forwarding in time using the Rust tests. So the function is called forward time. The first input parameter or argument of the function is program test context. I was talking about this in the slides regarding the testing using Rust. So when you test the program test environment, you should call, or you need to call, the start with context function that actually returns this type of variable. So yeah, these are basically the same. And then the second parameter is seconds, which is integer 64 bits. And then regarding the body of the function, so first thing we do, we actually fetch the system variable. In this case, the type is clock. Then fetch it from the Banks client of the program test context. Then the second step is we calculate the new timestamp we would like to move forward to. It's calculated from the current Unix timestamp, which is in the system, stored within the system variable. And then we add the desired number of seconds we would like to move in the future. So let's say it can be 5 seconds. For 7 days you need to calculate how many seconds there are, and so on. The next step is we actually update the clock with the new Unix timestamp. And then the last step is we can call the set sysvar with the updated clock variable, and we updated the system variable in the program test context. For the warp to slot and warp to epoch, this is also pretty simple because these are functions that can be called in the program test context, so the flow is actually even more simpler. And the arguments to warp to slot and warp to epoch are also pretty simple, as these are just numbers of, in the first case, slot or epoch you would like to move forward to. The second part is about testing using TypeScript. I split this actually into two options, as it might be pretty challenging to move a timestamp or move forward in time writing the TypeScript test and with the Anchor framework. So the first option I have specified here is actually decrease the deadline time. So instead of using some big numbers of seconds for the deadlines, for example 7 days, months, and so on, you can specify it for a few seconds. Then use function for TypeScript. It's called set timeout. So basically your tests are going to be sleep for the desired amount of seconds, and then continue with the test after the timeout passes. So when you decrease the deadline time, for example, for 5 or 6 seconds, you can wait for this small amount of time. I would say, or this is kind of disclaimer, because I think it might not be the most correct option, because it does not actually replicate the actual behavior of the smart contract, because if the smart contract has a deadline specified for 7 days and you decrease it for a few seconds, it might be considered cheating, but this option might be useful. The second option is to actually use the bank run, which is the also testing framework for the Solana programs. In this case, we can see the bank run actually can be used, let's say, with 2 imports in your TypeScript tests. Again, everything is in the materials, so you can check the source codes there. You can specify Solana bank run and then Anchor bank run imports. These two, or the second one, actually improves the experience of writing tests with the Anchor, so you can use bank run and Anchor hand in hand. You should keep in mind that it is a different context that Anchor starts actually, because the bank run uses under the hood the program test, the Solana program test, and the Anchor actually starts the validator under the hood. So you should keep this in mind. But the the flow of writing the test using the bank run and the Anchor framework is pretty simple, as you will see in the materials. For the setting up the new timestamp in the future, you can see the example source code. The first thing is we actually again fetch the clock system variable, then we obtain the current Unix timestamp, then we calculate the number of seconds which are in the 7 days, then we create actually new variable called clock, and we take the values from the fetch clock system variable, but with the, you can see the last parameter in future 7 days, which is the new Unix timestamp, the updated one. And then yeah, we take this new clock and we call setClock function, which actually sets the system variable, in this case clock. Then we are able to actually, or with this approach, we are able to update the timestamp also in the TypeScript tests, but you need to use the bank run testing framework with Anchor. In the right corner, you can see again the QR code. So this QR code points to the, I would say, official bank run website. So you can check it, you can check the docs, and you can also check the materials, how to use bank run within your Anchor tests. This is all from the part about forwarding in time within the Rust test and also TypeScript tests. And now the last thing I would like to talk about is best testing practices from the auditors and also from the developer's perspective. So let's continue. Based on experience as an auditor and also developer, I wrote these best practices, which I think are actually the best in order to increase readability, extendability, also correctness of your tests, and to increase the quality of your tests as a whole. So firstly, in my point of view, it starts with the understandable structure. That means you just wrote your Solana program and you would like to test correctly the Solana program. As I'm saying this, it is also important to test your Solana program part by part, not just to implement whole program and then start testing, but if you know the program is going to be robust, just write the first instruction, then write tests for first instruction, and so on. But yeah, the understandable structure is, from my side as an auditor, really important from multiple points of view. Firstly, from the auditor's perspective, it definitely increased the readability of tests. Imagine you are going to audit something and you just received the source code, or let's say the Anchor workspace, and you see the test file with let's say 2000 lines of code for tests. It is great that you have these extensive tests for 2000 lines of code, but for me as an auditor, it's from the first point, it is really hard to understand the test logic, and if you test the instructions and your Solana program correctly. For that, you can increase the readability of the tests by splitting actually the tests into multiple files, creating kind of environment for all of the addresses, signers, authorities you would like to include in the tests, and so on. For this purpose, in the materials we actually created as we created the examples. One of the example, in this case, I think the example is called Anchor test or something like that. Basically, example for writing TypeScript tests. You can see I included I would say, my favorite folder structure for writing tests when I develop something. So you can have a look, you can discuss, or you can decide if you like this folder structure, and you can reuse it for later development processes and purposes and so on. The second point is about testing also unhappy paths. For those who don't know what the unhappy path actually means, it's like sending invalid inputs to your instructions. Most of the time developers test only happy paths. That means when the instruction expects these kind of accounts and these kind of input arguments to the instruction, they just send the valid inputs, check if the instruction actually succeeded, and maybe do kind of assertions after the instruction. From my point of view as an auditor, it is really important to check also the unhappy paths. So that means you send the invalid account into the instruction and check if the instruction behaves as expected. So in this case, expected behavior is to throw error that this account is invalid or has incorrect type or has incorrect address and so on. Same goes for the instruction data inputs, I mean. So if the instruction expects values between 5 and 10, you try to send the 15, let's say, and check if the instruction behaves as expected. So in this case, it should throw error. The next point is about writing extensive tests. What does it mean? If your program has 5, 10, 20 instructions, it does not mean that you write one happy path test for each instruction, then you write one unhappy path test for each instruction, and that's everything. From my side, you should test each instruction multiple times, and it is not important if it's a happy or unhappy path, but basically multiple times. So yeah, let's say again, if your instruction expects one data input, in this case, let's say it's unsigned 64 bits long integer, or in this case unsigned integer, you do not test only one value, but you test also boundary values. If it's unsigned, then 0, and unsigned 64 max value, then also random values from the middle, and so on. We are getting closer with this approach to fuzzing, when with fuzzing you actually use random data for the instructions. But yeah, that's I would say, from my point of view, the best approach to test your Solana programs, to send it definitely or kind of guided random data, and you test if the behavior is expected. The next point is about the assertions. This means you do not focus only on the behavior, or only on the return value of the instruction, but you also focus on assertions after the instruction. That means when the instruction should update or initialize, can be also initialize accounts or update fields within accounts after the instruction passes or also reverts, you should, with using the assertions, you should check the contents of each account that was mutable within the instruction. So you can check, or you should check, if the updates were made as expected. Then the next point is about the random data or the advanced testing. I already touched this topic within the writing extensive tests. Yeah, the best is when you can test actually kind of randomly. So the accounts and the data does not need to be necessarily completely random, but you should bring kind of randomness to your tests in order to test the real-time, real-life behavior of the Solana program. So let's say you are developing trading platform. it is not enough to just test the trading for one value. For, let's say, someone wants to buy 10 tokens, but you should create kind of tests that generate random values for these trading amounts, and then test the Solana program with these random values. The last point, which is also pretty important, and it is like a low-hanging fruit, is use comments within the test. This can definitely, as first point, this can definitely increase the readability of your tests. It does not need to be like 20 lines of comments in order to comment every line of test. But yeah, if you develop something, or you have some kind of utility functions within your tests, definitely at least one-liner comment, this function is for this, this is the signer for this is the constant for this. It definitely increase the readability of tests. Yeah, so these are the points that I would like to mention here that are from my side best testing practices. And now we can continue to the recap. So at the start of this lesson, we went through the table about the integration test and unit test. We tried to compare them side by side, so you now know what are the differences and what actually integration test and unit test means. Then we touched also testing using Rust and testing using TypeScript. I think the TypeScript tests are pretty well standardized on the in the Solana ecosystem, but from this lecture you may also start writing Rust tests, as these are, I would say, also pretty simple to write. Then we were talking also about the Anchor manifest, how to actually clone programs and different accounts from different clusters, for example from the Mainnet or DevNet. Then we also touched issue about forwarding in time, both in the testing in the testing using Rust and also in the testing using TypeScript. So for the Rust approach, you can set system variable. For the TypeScript approach, you can use bunkrun, or there was the first option about decreasing actually the wait time. And the last point was about best testing practices from my auditors and developers perspective, I think, which are really important in order to improve quality of your tests and also actually at the end security of your Solana program. You can again see QR code in the right corner. This QR code is connected to the Helios block. This Helios block contains again guide about writing tests, so I recommend you to check the guide. It is actually the block, so you can read through the post, and yeah, you may learn something new. That's all from this lecture. I hope you enjoyed this lecture. And for the next week, you can look forward into the writing fuzz test. We actually split the lecture for fuzzing into 2 parts. So the first part is going to be about the introduction into the Trident. I will show you how to write tests, how to actually set up the Trident, how to read the outputs of Trident, and so on. So thanks again for your attention, and see you next time.